Welcome to the deep dive. Today we're going to be looking at the sun, really looking at it in a completely new light, you could say.
Yeah, absolutely. There's some really fascinating new data coming down.
We're talking about the sun's outer atmosphere, the corona, and that stream of particles always flowing off it, the solar wind. Some fresh insights here.
That's right. We've been looking at sources covering NASA's new instrument. It's called CODEX.
CODEX, okay. Coronal Diagnostic Experiment.
Yep, that's the one. And its first images are, well, they're pretty incredible. They're showing us what's really going on out there near the sun.
So our mission for this deep dive is basically to unpack what this data actually shows, what's new about it.
And why it's such a leap forward, right? Why understanding the solar wind at its source is so important.
Yeah, important for everything from satellites orbiting Earth to, astronauts in space.
It really is opening a new window. For the first time, we're getting a direct look at the properties of the solar wind, right where it starts, seeing it move in a way we couldn't before.
When you think of the corona, maybe from pictures of a total eclipse, you imagine this kind of shimmering, maybe relatively calm halo.
Right, that beautiful ethereal glow.
But the first data back from CODEX, it paints a really different picture.
Completely different. The big takeaway, the big reveal, as the sources put it, is just how dynamic and, frankly, messy it is.
Messy? How so?
Well, it's not this steady, even thing. It's, seething is a good word the sources used. Uneven blasts of plasma, gusty streams moving at different speeds, different temperatures. Much more complex than just a simple halo.
Seething. I like that. Gives you a real sense of energy. And these first images showing all this hidden activity, they were unveiled recently.
Yeah, at the American Astronomical Society meeting up in Anchorage, Alaska. Must have caused quite a stir.
I bet. So, okay, how are we getting this view? It all comes down to CODEX. What is this instrument exactly?
So CODEX, the Coronal Diagnostic Experiment, it's run by NASA, and importantly, it's mounted on the International Space Station.
Ah, so it's outside Earth's atmosphere. Clear view.
Crucial for this kind of observation. And technically, it's a solar coronagraph.
Right, coronagraphs. We've had those before. The idea is basically to make an artificial eclipse, block out the sun's bright face so you can see the faint stuff around it.
Exactly. That's the core principle. Like the moon does naturally, but CODEX does it on demand.
Like a tiny, perfectly placed moon inside the instrument?
That's a good way to think about it. You use these small disks, they're called occulters, about the size of a tennis ball, apparently.
Huh, small.
Yeah, held out on these thin arms at the end of a tube, precisely blocking the sun's disk.
And older coronagraphs, like LASCO on SOHO, they were good for seeing things like solar storms, right? Big eruptions.
Yeah, LASCO is fantastic for that. Seeing those huge coronal mass ejections, CMEs, invisible light, gave us these wide views of material blasting out, measuring its density mostly. How much stuff was there?
Okay, so LASCO saw the big blasts and how dense they were, but CODEX, this is where it's different. What can it measure about the everyday solar wind, the constant background flow?
This is the game changer. For the very first time, scientists can use CODEX to directly measure both the speed and the temperature of that solar wind.
Both speed and temperature.
Both. And specifically for that slowly varying wind, the stuff that's always streaming out, not just the massive occasional eruptions.
Wow, okay. That feels like a huge gap filled. We could see the stuff, maybe infer things, but not directly measure speed and temperature right near the sun for the steady wind.
Exactly. The direct measurement capability is what's brand new here.
So how does it do that? How does it get speed and temperature? Is it still just taking pictures?
It's more sophisticated than just a simple picture. It uses specific wavelengths of blue light that are emitted by the plasma in the corona.
Blue light?
Yeah, around the 400 nanometer range. It has these very narrow filters. By comparing the brightness of the corona through different filters, say one at 405 nanometers and another at 393.5, they can figure out the temperature.
Ah, so the ratio of brightness in those specific blue colors tells you how hot the plasma is?
Precisely. And for speed, they look for tiny shifts in those wavelengths. Doppler shifts, basically. Tells you if the plasma is moving towards or away from the instrument and how fast.
So it's analyzing the quality of the light, not just the brightness or shape, really digging into the physics encoded in that light.
You got it. And the visuals they're creating are amazing. Like these color-coded maps showing temperature changes across the corona over, say, a couple of days. Red for hotter areas, purple for cooler. You see this dynamic temperature structure unfolding.
Incredible. So just to recap for listeners, the solar wind is this constant stream of charged particles, plasma, flowing out from the sun.
Right. Always happening.
And Codex is looking at structures called coronal streamers, those sort of ray-like things you see in eclipse photos.
Yeah, those are shaped by the sun's magnetic field, and they're like channels for the solar wind. Codex is basically looking inside these streamers to measure the wind properties right there.
Okay. So we have this new tool measuring speed and temperature directly at the source. Why is this such a big deal? What are the implications?
Well, scientifically, it tackles a really fundamental question in solar physics. How exactly does the sun's incredibly hot corona accelerate this wind? We knew it happened, but the details, the energy transfer, it's been tricky.
We couldn't quite see the engine working.
Kind of, yeah. Previous instruments gave us clues, but not these direct measurements right at the source. Jeffrey Newmark, he's the principal investigator for Codex, he was quoted saying, "We really never had the ability to do this kind of science before."
Brand new observations.
Exactly. He stressed that the Codex instrument is doing something new. It fills that observational gap.
And the practical side, down here on Earth or, near Earth.
Space weather forecasting, that's the immediate, really vital application.
Right, because solar storms, CMEs, even variations in the solar wind, they can mess with our technology pretty badly.
Oh, absolutely. Satellites are vulnerable. Power grids can be affected. Even astronauts doing spacewalks face increased radiation risk. It's serious stuff.
So, knowing the wind speed and temperature right as it leaves the sun helps predict its impact when it reaches Earth.
Precisely. It gives the modelers much better starting conditions. Instead of guessing or inferring the initial state, they have actual measurements. Okay, the wind leaving this region has this speed and this temperature.
That must make the forecasts much more accurate.
That's the goal. It provides crucial constraints for the models, helps them simulate how that plasma cloud or stream will travel through space and interact with Earth's magnetic field. It's about better understanding that whole Sun-Earth connection.
It really is like finally getting to measure the river right at the spring instead of just guessing based on how fast it's flowing miles downstream.
That's a perfect analogy, characterizing the energy, the flow, right where it originates.
Okay, so let's wrap up this deep dive. Key takeaways. The sun's corona, far from being calm, is actually this incredibly dynamic, seething region.
Yep, much more complex up close.
And this new instrument, Codex, on the ISS, is giving us totally new data, direct measurements of both the speed and temperature of the solar wind right near the sun.
Measurements we've never had before, especially for that continuous, slowly varying wind.
And this isn't just, cool science for the sake of it, though it is cool. It has real-world importance for predicting space weather.
Vital for protecting our technology, our infrastructure, and astronauts as we explore further out.
So, thinking ahead now, with this brand new, super detailed view of the sun's hidden dynamics, seeing these subtle variations right at the source, it kind of makes you wonder, doesn't it?
What else might be going on?
Yeah. What other forces, what structures maybe, are shaping that space environment right around the sun, the environment our planet travels through, and, how will understanding those details help us protect ourselves even better and maybe push further out into the solar system?
It's an exciting time for solar physics. These observations are just the beginning, and they really open up new avenues for investigation. Lots to think about.